I've been around in the mesh credit world for a while, and I'm not particularly super excited about blockchains as I used to maybe 10 years ago. And so I'm very excited to hear Kyle's presentation, who runs MyCHIPS, which is a mesh credit network that does not rely on a blockchain. Just to give you a bit of a teaser. Kyle, please take it away.
How are you? Everybody having a good time? Okay, don't yell it out, but if you know what this is, lift up your hand. Okay, if you don't know what this is, lift up your hand. Okay, so this is quite an informed audience. I've only found 2 people in my life back in the United States who have ever been able to look at one of these and figure out what it is, and a lot of people here know. Will you hold on to that? So it also looks like this in a little bit later iteration. And do you think you could hold this mic for me for a second, and so I can use my 2 hands? This is called a tally stick, and this was a payment form for about 800 years, from about the 1200s to the 1800s, at least in England, I know, and perhaps other places as well. And it has some interesting things about it. This piece on it is called the stock, and this smaller piece is called the foil. And you match these up by looking at the grain, where the wood is split. And the notches are called chits, and they tell you how much this is worth. And it's a credit contract, and it's a form of money that was used for quite some time. If you know, in English, we have a thing called the stock market. We have stocks and bonds. And that's where this term has come from, is the stock, because you would give the stock in consideration of a purchase, and that was the part that was of value, the positive pledge of value. And the foil was the copy, carbon copy, to help you understand what that was. And we also have another idiom in English that says, I got the short end of the stick. That means that I was the one who ended up the debtor in the relationship. So that's pretty cool. And I like these as a reminder that private credit money has been used successfully for great periods of time throughout history. And really, it's only relatively recently where we have not had much of an active private credit money functioning. Now, we're going to do kind of a little interesting role play here to show you how the tally stick works, and we're going to demonstrate one of the problems with private credit money that has to be solved. And I call it the fungibility/trust trade-off, and so we'll do that next. So if you guys want to come up here. So let's start with maybe Alex on this end and Michael in the middle. And so we're going to set up a purchase, and Alex is going to purchase something from Michael. And so he's going to give him the stock, which is the big one, in consideration. And they've now made a promise. Now, this tally stick is a promise from Alex. And so he's the issuer of the money. He's the one that needs to be trusted in this relationship. And we're presuming that they know each other and they trust each other, and that's just fine. But at this point, Michael wants to buy something from Julio. And so we have a question: are these credits going to be transferable, or are they not going to be transferable? Now, if he tries to buy something by transferring that to Julio, now we've imposed a relationship, a requirement that Julio has to trust Alex, but Julio may not know Alex. He may not want to trust Alex. He may not have a basis for that. So that's kind of what we call the trust issue with private credits. And mutual credit kind of solves that in a different way, and MyCHIPS solves it in a little bit different way. I think each of our systems tries to solve that in a little bit different way. So let's undo the transaction. Let's go back to where we were. I'm going to give you this one, and I'm going to give you this one. Now, we've been doing this exercise in different ways all week, so I'm not going to go into depth about what's happening here. But we're going to have a purchase, so the stock is going to go this way. Okay, we're going to have another purchase, but we're going to use a new issue. We're not going to use the same tally. We're going to use a new tally, and we're going to pay over here to Julio. And now we're going to go back the other direction. Okay. You can stay here, Julio, but just hand the stock down to Alex. No, wrong stock. Wrong stock. Oh, you switched? Did you switch? Okay. Okay, so we're good. So we have three different issues of currency going around the circle. Nice. That's awesome. Good deal. And so now we have kind of a fungibility issue. Is the purchasing, the normal way that purchases are happening is in this direction. And usually if you have somebody that you buy things from, that's usually not the same person that you're going to sell things to. Sometimes it happens. Sometimes that's convenient. But oftentimes we go to one person as our employer to get our income, and we go to a vendor somewhere else. So this is the fungibility problem. And we're solving it with what I call a credit lift in MyCHIPS, what has been referred to as credit clearing, which is kind of half of a credit lift, as we'll go into a little bit later. And what we need to do is get a way for these three people to agree, because we want to clear this credit out. Now, if two of them agree and the other one runs away in the middle of the transaction, we're going to be left damaged. And so Michael has an algorithm, and he and I kind of came up with a very almost identical algorithm independently. But he's going to demonstrate his algorithm in kind of an intuitive way, how we're going to undo this.
I'll try. Yeah, and we're not the only ones who came up with it. So Bitcoin Lightning uses a similar thing. Interledger uses a similar thing. And Ryan Fugger, when he invented original Ripple in 2003, first he said, well, okay, well, let's have a database server called Ripple Pay. But then later he said, well, wouldn't it be better if it was federated? But how could we do that? And then in 2008, he made a post to the mailing list. This was before Bitcoin. And he said, well, actually, with a hash lock, he didn't call it a hash lock, but he said, well, if we do some sort of riddle that if you can solve the riddle that acts as a delivery receipt, and then we do staggered timeouts, so we can do multi-hop with a hash lock. So here comes a bit of a computer science. I'm going to try to explain what a hash lock is. So I can think of three ways to solve this, right? Obviously, what we want is we want each person to keep their things, but to have their tallies back, so that we're clearing the debt loop. So one way would be to use a database, or we could all put our information in a database, and then you could just run a search through the database, say, oh, I see a cycle there, let's even that out. Another way would be with a blockchain. So you don't rely on a single database, and you don't have to trust one party that's going to clear all the debts for everybody. We say, oh, well, let's have a smart contract that we can all trust, and it's decentralized, etc. The third way, which I'll demonstrate here, is using peer-to-peer messaging. And that's the way we know how to do that, is with a hash lock. So first of all, I'll tell you that you can have your, this was your stock, you can have it back. You can keep my phone because you bought it. I'm happy with his phone. So that's all good, but we want to reset the debt loop. I'll give it back to you, but you have to promise me that within 30 minutes, you tell me the answer of the following riddle. If you can't tell me the answer within 30 minutes, then I'm going to keep the stock. Then you stay indebted to me. So the riddle is, what is pink, wet, and fast? Now, you have 30 minutes to solve that riddle. I'm already giving it back to you, but just conditionally. So I'm conditionally giving it back to you. And I trust you to just, yeah.
So it's like that's what they do now. Okay. So Julio, I'm giving you back this conditionally. If you tell me what is pink, wet, and fast.
Pink, wet,
and fast.
Within 20 minutes.
Okay, so can I answer the riddle, or should I give you?
The answer.
I don't know the answer.
Yeah,
Okay. So what do I do?
So you can give me my stock back conditionally,
Okay.
square one,
Okay.
on the condition that I.
Give me the answer.
Yeah. Okay.
What is pink, wet, and fast?
A flamingo in a bathtub on a train.
Ah.
Okay, so we're good. Okay. I got my stock back. I'm good. You still have the answer. 20 minutes left to.
So what's the answer? What's the answer?
A flamingo in a hot tub in the train.
You can keep my stock. Thank you. So now, okay, wait. So now I come to you.
Yeah.
And now,
I said I gave it conditionally to you.
yeah. So now I tell you about the flamingo and the hot tub and the fast train, and
Good. Okay. We're good.
I can keep your. Great.
So everybody has their stock back. I have a very nice phone. You have a very nice phone. You have a very nice bit of, and we did a trade, and we're all back at zero. So that's how a hash lock works. In a real system, usually they use the SHA-256 function. So I generate a random string, blah, 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 and then I say I take a one-way function to get another random looking string, and I say, can you tell me the pre-image of this hash? And then that's how you commit the conditional payment. But it's exactly the same. Like the hash is a riddle. Tell me what pre-image produces this riddle. So that's how hash locks work.
Kyle.
Good job. Thank you very much. So I like to make these tally stick replicas in order to go around and teach people about private credit. And I brought a bag of them that I'm not taking home as gifts. So there's not enough for everybody, but if you feel passionate about it, I'll give you one. And if you did not get one and you want to make contact with me, I will make you one and send you one. All right. Thank you. I also brought some T-shirts from the Got Choices Foundation. If anybody fits into or likes one of these T-shirts, let me know. If you'd love to collaborate with me on something, you definitely get a T-shirt. And if you don't want to collaborate with me and there are T-shirts left over, you definitely get a T-shirt. All right. It's been really a pleasure to be here. I come from a little bit different background, a little bit different story in my life than the rest of you. And so it's been particularly enlightening for me to hear your stories, to hear your projects, and to hear what you're doing. In fact, I heard in a Monday session that there was no such thing as free will, which scared me a little bit because for the last 10 years, I've been working on the Got Choices Foundation, which is all about free exercise of free will. So I wondered if I'd been wasting my time for the last 10 years. And then it occurred to me that this guy had every right to believe that there was not free will. He could choose to believe that there was not free will, and I could choose to believe that there is free will. And that's the wonderful thing about free will, is we all get to choose, isn't it? So that's what Got Choices is all about. And so why is Got Choices sponsoring a money project, you may ask? And back in 2014, I started writing a book, and I identified what I called 3 pivots, or you might want to call them levers in society or in economy, that are very powerful things by which we often find our free will infringed, our ability to exercise our free will infringed. And money is perhaps one of the biggest ones of those. The way money is designed, the way money is implemented, the way money is distributed, created, has the potential to be very unfair to people. That's not always unfair, as Alex pointed out. I think there's honest money out there, and I think there's dishonest money, but it has a huge potential for damaging people, and as some of the terminology was, for extracting value against the will of the people who are participating. So after I wrote that book, I was interested in how I could go about making a little better money system. Bitcoin was just coming along at that point. I studied Bitcoin. I'm a longtime computer programmer. I quickly became convinced there were some fatal flaws with public blockchain for implementing a worldwide currency, mostly scalability issues, but there were also some monetary theory issues that I disagreed with. and started trying to design my own system. And by the way, there are 2 other pivots in that book if you have any interest in learning about that. So I had prepared a presentation full of lots of economic theory, monetary theory. That's really been covered in depth this week. I'm not going to go into that. We're going to skim very quickly through the theory parts, and I'm going to give you just the parts that I think are most relevant to MyCHIPS and how it makes a difference to the design of MyCHIPS. These are some of the design criteria that I had when I wanted to say, gee, is there a better way we could make a market system, a market-based system? And by that, I mean individual people could issue currency. Alex talked about a lot of myths. I want to say one other myth that occurs to me is that banks make money out of nothing. Sometimes they do. But the honest money, they don't make money out of nothing. They make money out of us. Out of us. Okay, we give a note to the bank gives us credit back. So we're the issuer at the end of the day. And we're in an age now where with Uber, we don't necessarily have to go through a taxi company. We're able to connect the driver and rider directly together. And I believe that we're in a technological age now where we can do the same thing with credit, is we can put the borrower and the creditor and debtor directly together, and we can plug them together, and we can bypass a lot of the overhead that's in the system. So in trying to make this system, we've talked about 2 different kinds of money. Credit money and commodity money is what we've been saying. I'm going to call it equity money. Why are there 2 different fundamental types of money? Why is that? How many people do we have in here that are trained accountants? What's the accounting equation? Okay, it's at the top of the screen right there. Assets equal liabilities plus equity. When you get into accounting, you learn that. You think, okay, that's great, I'll learn that. But I'm here to tell you this has deeper significance than just how to do your books. Assets, something of value, equals, can be claimed by 2 fundamentally different types of things. One is a liability, which is denominated in a value. It's a fixed amount of debt with usually an interest rate attached to it. And equity. Equity is very different. Equity is ownership of the asset, and liability is a claim to value, which is backed by the asset. Okay, now it's important for us to understand why there are these 2 different types. When you go into the securities market, guess what? We have stocks and bonds. There's this natural division, okay? And I go into this in a lot more detail. I'm not going to belabor it, but I'll tell you that when we build money on the basis of equity, we have a certain set of features and benefits, and we have a certain set of problems to deal with. Same thing when we go into credit money, certain set of features and benefits, certain set of problems. Okay, let's talk about equity money for just a moment. And sorry, Alex, I drive Alex crazy because I use this terminology, but I've been using it for years, so it's a little hard to break. Equity money lives on the assumption of private property rights. We sometimes take that for granted, but if you're going to own something, your culture has to accept the notion of ownership. If I think I own this bicycle and all my neighbors don't agree that I own this bicycle, I don't own the bicycle, okay? There has to be this public consensus amongst the community that you own that bicycle, and there needs to be a way to understand that and honor that. The equity money tends to be a little more cumbersome, tends to be more of a tangible asset. Now, one of the reasons I call it equity money instead of commodity money is because I'm putting Bitcoin in this bucket, because Bitcoin is clearly not credit money. And so we're enlarging the concept of commodities to just include something that you can own. And Alex's presentation helped us set the stage for that. It's rather difficult to digitize equity money. Bitcoin has found a way, and at some expense. has found a way to digitize the equity. The problem is that you end up with an equity that is not really worth anything. Now, I showed you the example of the split tally stick, which represents a credit agreement. This is my model of a public blockchain token in the same model. Okay, it's not a split tally. There's only one of them, and I can give it to someone if they think it's of value, if there's enough demand for it and they think it's valuable. This is kind of like a non-fungible token, maybe more than a Bitcoin analogy, but it gives us kind of the conceptual difference that we're dealing with. This is a monopole and credit is a dipole. They're two opposing pieces, so keep that in your mind. Okay, we're going to go to the next one, which is credit money. This one also requires some kind of a cultural norm in order for it to have value, and that is that we have to understand the idea of a contract. We have to be able to make an agreement with another person, and not only does that contract have to be enforceable, but it has to be allowable. Okay, so sometimes governments will say, we're not going to even allow you to make that contract. And so you have to have a certain amount of freedom to make contracts, and then you have to have some way to enforce the contract. Now, I'm not saying you have to have a government necessarily to enforce the contract. A lot of times reputation is enough, and trading relationship is enough. The stake that people have in the trading relationship can be enough to enforce that. It's much more nimble because a contract can easily be represented in a digital form and can easily be signed and validated in a digital form. It has the challenges of trust and fungibility, which we demonstrated up for you up here at the beginning. And so we have to deal with those issues in the same way that blockchain has to deal with the double spending problem and the mining. You know, how are these tokens going to come into circulation? Well, we kind of invent this thing of mining so that there's a fixed supply and they can come in. We deal with how they're going to be issued. In private credit, we have to deal with trust and fungibility. Those are the two primary issues. Okay, so we're going to go on to the design. My top 3 priorities. Okay. I want you to understand that I'm trying to emphasize something here. What am I trying to emphasize and why? Why is scalability the key here?
Like I said on Monday, either we scale up or we go out.
Okay. Other thoughts?
Because they don't can be open.
Okay. And I almost put it in the opposite causal relationship, is that if it's open, it will be scalable, right? Why do we need something that is infinitely scalable? Okay, that's good. Now, if I just come out with something that is on a single database and I try to get subscribers, how far is that project going to go? You know? Yeah, and if I say, look, this is a proprietary system and you got to pay me a licensing fee, how far is that going to go? It's not, no matter how powerful you are, you're not going to be able to get the whole world to adopt this. So it has to be scalable. I've shown open protocol. I see that as a subcondition of scalability. It's a way of achieving scalability. Independence is a standalone issue that I feel very strongly about, is that MyCHIPS had to be independent. And by that, I wanted it to be independent of any other currency. I didn't want it to be pegged to a currency. I didn't want it to be dependent upon any architecture out in the cloud. I didn't want it to be dependent on any sort of libraries that were not open source, freely available. And I didn't want it to be based on any sort of authoritative addressing, such as DNS. Okay, so the protocol has been built so that as long as you can get on a network with an address that you can communicate with your trading partner somewhere else, at least intermittently, you'll be able to operate on this network, okay? So those are the design principles. Now, we have a prototype application that you can download. I'm showing you a screenshot from the app. And we're going to talk a little bit about what that is. We talked about the tally stick. And I have adopted the terminology of the split tally in implementing MyCHIPS. So we use that terminology. So when we are going to trade with someone, we are going to tally with them, or we are going to make a tally with them. And you can have a stock and a foil, and the stock is typically associated with the person who is selling, and the foil is associated with the person who's buying. Okay, and what happens is you get into the app, you generate a barcode, and that's a tally invitation. You communicate that barcode to somebody in what I call an out-of-band communication. And it does not go through the protocol. So you need to email it to them, or you need to text it to them, or you can show it to them on a computer screen, in a video conference, anything like that you want to do. This is the key, and they can scan that on their app, and then that forges the connection with a one-time connection token. What happens as we build these connections is we build the network of trust. I'm not going to go through all of these features one by one. We've all seen these graph networks that are built. I will tell you that it's possible to quantify at each level of the network. It's possible to quantify the amount of trust, quantified in chips. And when you say I trust you 10, you're saying a couple of things with that. You're saying that you may pay me up to 10, and I will issue you net credit terms. For example, net 30 is going to be very common in the contracts that will be embedded in MyCHIPS. That means that it's interest-free during that period of time, as long as you reconcile out or redeem that back out during that period of time. And it also says I'm prepared to lose 10 from you. And I don't know if this maybe addresses your question a little bit, is, how do I take that risk? So you need to in your mind say, I'm prepared to lose 10. But when I lose 10, you're going to lose connectivity to the network. Okay, that cuts you off. And so there's an incentive for you to honor the 10, because that's how you honor that relationship. And it's also how you're going to get access to the rest of the network. There are also some other things that are reputation-based that can be add-ons to this that can harm the reputation of the person who breaks that trust. Every person in the network, in order to function, really needs to have what I will call one upstream tally and one downstream tally. So upstream tally is one where we traditionally get paid, and a downstream tally is one where we traditionally pay. Now, having said that, there are some exceptions. The balance on these tallies can go in either direction. So just because we call it upstream or downstream is just kind of a convention that we set. But you can carry a balance in either direction on any tally. If two people want to join just together and they have a bilateral trading relationship, they can do that with one tally each. So if you have a guy that you go to lunch with periodically, you guys can establish a tally, and you can keep your lunch tab back and forth. And so MyCHIPS will work in an ecosystem of two people to 2 billion, 8 billion, however many you want to add. And as new people come on, they're going to bring their own storage and their own processing power to the game. Okay, as you establish these trading relationships, they're going to show up on your app. And we're looking at what's called a tally view. And you can see at the very top, this person has 76 chips. And if we go into a special session talking about the chip valuation, I don't know if you have any interest in that. That's one of the afternoon sessions I proposed. If we do one of those, I can go into all kinds of things about what a chip is and what it's worth and how we value it. But you can see the chip there. And then because I'm from the US, I can choose to also display those in dollars if I want to. And I can come up with my own conversion for the chip, or I can rely on an estimate that is part of the system if I want to. If I click a certain button, I can see a graph view of my relationships, okay? So this person in the middle, and I call this a visual balance sheet. What I wanted to have is something that would give someone a quick visual understanding of kind of where they stand. with their trading partners. So you can kind of see your net worth in the very middle. You can see assets and liabilities on the next ring. And then on the outer rings, you can see the individual tally balances and whether they're in the blue or in the red. And then you can see your trading partners. And that obviously could become a very busy graph if you have hundreds of trading partners. May not be feasible for certain things, but for simple ones, it is very helpful. Now I want to talk about the notion of a site. A site is a database. Okay, we mentioned that we wanted this to be scalable. And so in order to be scalable, it is almost 100% completely distributed. Now, for those of you who are programmers who understand the difference between centralized, decentralized, and distributed, if you have a question about that, come and talk to me after. I'll show you the topology. But essentially, the mesh network is distributed. And in all cases except one, where Mikhail said after 30 minutes, this is going to go dead, I have a very tiny bit of ad hoc centralization that enters in order to say, when is the 30 minutes up? And by ad hoc, I mean those three people would choose a referee at the very beginning of the transaction. And that's one little tiny piece of centralization that is entered in. And with that, we can make a transaction that is safe and live. So if we look at a site, we're going to see this site has 4 different users on it. And you can see a couple of connections there that go from user to user within the same site. If you get a rich enough topology within a site, you can do lifts. And again, when I use the word lift, I'm talking about a clearing function plus, which we'll explain in just a minute or two. So I can do lifts within a single site, or I can have segments where I can participate in distributed lifts with other people. And you saw a distributed lift here with the, what do you call it? The hash log, but you had a whispering merchants protocol on his website. So when you get a series of sites or databases, it looks kind of like this. So I have site A, site B, site C. We've looked at node graphs with individual people. What MyCHIPS does is it then zooms out and it looks at individual databases as though they're nodes in a larger, maybe more simplified graph network. And so let's look at user B2, who has a credit imbalance that he wants to clear. He can send a message. The agent that is running the site can send a message up to A3 through B1 and say, hey, is there any chance that you know where B3 is from your perspective? And that whisper protocol can work its way up through the network. It gets split into many different pieces as it goes, and it either finds a destination or it doesn't. If it doesn't find a destination, then other forces will kick in. But if it finds a destination, goes through the cloud, comes back around up through C3, and C3 says, yes, absolutely, we do know about B3. He's not on our site, but we know how to get to B3. That message is propagated back and cached on site B. And there's a large pathway table that can maintain a database of possible paths. When we're ready to do the actual lift, we send a riddle, we send a cryptographic hash out, and if that hash makes it all the way around the circle, that's the phase 1 commit. Phase 1 of that's phase 1 of the lift. And if it comes back with the proper signing, that's the phase 2. Okay, so that's kind of how that works. Now I want to talk a little bit about lifts and how they are different. MyCHIPS, I think, goes a little bit beyond some of the discussion that I've heard so far this week. Specifically, I've heard about credit clearing as something that we really want to net to zero. That we really, these credit imbalances, they're promises, but we kind of need to get rid of them. We need to clear them. We need to smash them down. We need to get them all to net to zero. And in the process of doing that, I guess what we're doing is we're working our way towards some other ultimate reward in the system, and that might be fiat currency, that might be Bitcoins, that might be something else that we're trying to get to. MyCHIPS takes a little bit different view and says, I don't necessarily want to net all of the credits to zero. I want to put the credits where I want to put the credits. Okay, so we have a graph right here of just 4 simple trading partners. Assume you are B and credits or payments are coming to you from A. What is your relationship with A? What is A to you? Yes. Okay, a client. Did you hear that? So you are selling services. You could call it a client or an employer, depending on how you're thinking about that relationship. So A is paying B and B is paying C. So if I accumulate a bunch of credits here on the plus sign of B, what are those good for? If your employer keeps giving you promises, those are not really that valuable to you. Actually, they are in MyCHIPS, but I'll explain that in a minute. But where the credits might be more valuable is down with C, which is your grocery store, where you like to buy your food. Okay, so what you do is you go into your settings, and I'm going to just jump to another screen here for just a second. You go into your settings and you say, you know, I really would like to accumulate 1,000 chips down there on C, and I really don't want to have more than about 100 at any time on this A. So those parameters go into the algorithm, and as lift opportunities come through, those are honored, and eventually those credits will transform. I call it transmute. They kind of disappear out of one side and they reappear on the other side in the format that you want. This is a live graph that kind of what I use to generate the algorithm, and it's live. You can experiment with it and set the parameters. So this tally balance is saying that the client right now owes the vendor 660 chips, and then we have a target. And you just say, you know, I really would like to have about 400 chips on this tally all the time. You know, I'd be totally happy having 400 there. And over on the left side, we can see what size lift can be accommodated through this. Those parameters are embedded into the database, and so you can calculate the lift capacity of a channel at any point in time. No, they don't have to. And it's beautiful. And it'd take me a long time to get into that. But you can set your target. You are not guaranteed to have your target, but there is a thing called a clutch. And I'm not going to go into those today. It's quite a lot. But there's a thing called a clutch. And think of clutch as grabbing. You can say, you know, I really, really want to hang on to these. And if they go away, I want a fee. Okay, that's kind of what this means. So you have lift pathways that are free, and you have lift pathways that are at potential cost. And if you really, really need to push something through a difficult pathway, you have the option to push uphill, as it were, something that somebody is not their preference, but they're willing to for a cost. You can push money through at a cost. But if I owe you money, so right now 660, it's free for me to take that 660 back to zero, because that's an IOU. I owe you, so I have to honor that. I have to honor the terms of that. If I go beyond that 660, now I have to start to honor these other preferences that are put in place. But because the client target is at 400, right now I can go from 660 all the way to 400, which is the 1060 up there on the left where it says a normal lift. A normal lift can be done for 1060, and then at a cost, I can go another 400 up to that 800. So this is fairly complex, and this happens at each node in the network, and so the system can calculate a lift capacity all the way through. Any questions about that before I go off that slide? So for me, the lift is more than just a payment system. We're not accumulating credits just with the hope that I can get them put back to zero. We're accumulating credits in order to use them to buy things. That's money. Okay, so that's why I think this qualifies as money if we use it as money. Now, I won't say that this is where you're going to store your long-term value, and there is a strategy here for even creating chip loans, chip mortgages. And so, for example, if you're living on more of a day-to-day way and you have savings, you have the potential for savings, there's a way for you to lift money into a credit line, which is in association with a car or a house or something else. And so you can gradually peel value off of this. And instead of saying, I'm going to store my value in fiat currency, you can store your value in your home. You can store your value in a tangible asset. But very much for 30, 90 days, for months at a time, you can store temporary value right in the chips. And you would normally do those with the vendors that you have day-to-day business with, and you can spend that money as you need to. Now, I mentioned that you might not want to accumulate credits from your employer up here, A. Now, I'm going to give you the exception to that. If your employer is a very solid company and you're very comfortable with that, it's a great place to store your credits. And you can save them. And instead of doing a clearing function, which is a circle, you can do what I call a linear lift. Okay, it's a ripple payment. The linear lifts always go upstream of the arrows. And so you can make a payment from B to A to D, and you can pay someone who you don't know. Now, by storing those credits in your A tally, that facilitates those payments very easily. So you can pay lots of people you don't know from the credits that you're storing up in your A tally. You can pay C very easily from the credits that you're storing in the C tally. You can also pay people you don't know with the C tally. It'll work either direction.
Would A need a money transfer license to facilitate that?
So I don't know how to tell you about other laws besides the United States. That's beyond my scope, but I will tell you that we're studying this very carefully, and I do have a legal opinion that has been written, and we believe that this falls under the what we call safe harbor under the SEC regulations in the United States. And it says this is a net credit. This is a net 30 credit line established in the normal course of business, and that the people, at least of the United States, have the free right to associate with each other and set up these kind of credit relationships. So we're hopeful that it's going to be great. Now every country is going to have their own political issues to deal with. Great. So you're storing value in credit-based contracts, and it doesn't necessarily have to be something that you're clearing to zero. Listen, I've gotten to the substantive end of what I had. I wanted to leave a little bit of time for question and answers, and I also wanted to be able to show you some areas that you could go for other information. I will say that if you'll go to mychips.org, that's kind of a clearinghouse for information there. You can find the original book. You can find the MyCHIPS papers. You can find the study on the lift algorithm. It's a mathematical proof of the lift algorithm and why it's cryptographically safe and why it can be counted on to complete. This is where we are in the project. It's not ready to be used yet commercially, but it's getting close. I would love to have collaboration with people who can help me get it there. A great deal has been done in the substantially complete category. We're working on the mobile app. That's really the biggest thing right now, and there are a few things in the back end that need to be finished, that need to be brought in. The back end is complete enough that it will run in a simulated mode, and there is a simulator, and it's possible for you to download the software if you're interested. Run the simulator, launch any number of instances. It can generate data sets, and it can show lifts. So at this point, I think we have about 13 minutes. Julio, tell me what our time is. How much do we have? Will you stop us when we should stop having questions? Okay, so are there any questions you want me to go into? Maybe not. Oh,
value of the chips against the other. So it should be stable. So
okay. That is a big question that I won't have a lot of time to answer here, but if we go into the chip valuation, I will answer that in depth. But I will say that each tally has an encoded contract in it. And the contract is a written document that you can print out. And we hash that document, incorporate it into the hash of the signed hash that you agree to. And so it is a legal document and can be enforced if you share a jurisdiction with the person that you're working with. In that document, it says this is what a chip is. And it's about 6 bullet points that describes what a chip is. And so I will say it has the definition, which is better than $1. It's not quite as easy to define what a chip is as it is to say what an ounce of gold is. But if we go into that discussion, I'll explain in some depth a bit more about what a chip is. Okay, deal?
Hi. Thank you very much. Really, top-notch stuff. Cory Doctorow wrote a book called Down and Out in the Magic Kingdom, which is great fun. And in it, he imagines a reputation currency. This is a little bit of a build-up, but I get there quite quickly, I promise. A couple of years later, he wrote a blog post saying, "This is a terrible idea. Don't do this. Just because I wrote a book, don't think that I'm doing this." And he describes in that blog post the eBay long con. And the eBay long con is you set up 3 or 4 eBay accounts, which are free to set up, and you do lots of trades round them for $10 each. And you get a nice big eBay score. And then you say, "Oh, look, I've been doing all these little things, but now I've got my car to sell and it's $10,000. But look, I've got a really high reputation. You can read all my reviews, blah, blah, blah."
Is your question, can I do that on MyCHIPS?
Well, my question is about your governance mechanism when someone fails. So you said if you say you trust them for 10, and if they fail, they get thrown out. Right.
They don't get thrown out, they get disconnected by you.
Only disconnected by you.
Yes.
Right.
Now, there are some add-ons that we could go into maybe in a different setting where it is possible, not through this protocol, but externally to set a reputation for that person. But that's not what we're going into here. The point is they lose their connection from you, and that's the end of the consequence
So
at that point.
You have an answer to the long con problem.
Well, that problem.
You don't have to
that
prove
problem.
it to me, I believe you if you say
That
you
problem does not exist because you don't execute tallies with people based on their reputation.
Okay.
Period. You execute with them because you know them already. Yeah, let's take one right here and then we'll come back to Mikhail.
Thank you for the presentation. Pretty amazing, and like being totally fun. I really want. Could I have one later? Like
yes, you can.
Thanks. Yeah, I was also interested in how you deal with failure, and but if I understood right, is basically all a bilateral agreement system where I decide how much I trust somebody, and based on that, I'm basically acknowledging that trust is risk, and if so at the other end, so the foil, right? Foils.
Yep.
I'll take the loss.
You will take the loss.
So it's pretty, in this sense, like a sovereign
Yes.
sort of system where all agents take full responsibility on trust.
And it is not
risk.
it is not amortized across the
There's
community.
no like
Correct.
risk sharing buffers.
And that's
whatever.
how we achieve zero inflation.
And so
That's
you're
important.
connecting that to issuance. And the
If you
issuance
issue it
protocol.
and you default, the failure stops right there.
Okay.
Yep. And by the way, a tally can function on zero trust in one direction. It does need non-zero trust in at least one direction, but you can have zero trust in one direction.
How are you solving? Is there any Sibyl resistant mechanism so I don't go and like fail once and try again? Like, of
With-
course, in real life wouldn't work.
Yeah.
So,
If it's with a new person, every time there's not a built-in mechanism, that would have to be an external reputation problem. But essentially, if you know the person, if you're executing tallies only with people that you have a relationship with, you know who the person is. And because you have a legal document, you may actually be able to go to court and collect.
So is there some sort of Ricardian contract underneath?
Yes.
So there's
Yes.
there's a
Yes.
possibility for legal recourse.
There's more than just a Ricardian contract. There's a contract with a chain of contracts, and it's very contracty. There's lots in there that you can print out and show what you agreed to, and you can actually list collateral. You can attach collateral to, as long as this is legal in your jurisdiction, the platform will allow you to do it.
So it's basically a platform of private contracting.
Yes.
And like the transitive nature of it
Yeah.
makes some externalities possible.
There is
Okay?
one little evil hook in the license is if you purposely cheat your partner, you have violated the open source license.
Well, that's a nice twist.
Little hook. So,
Uh-huh.
yeah. Okay. Michael, did you have one?
Do you think there will be market makers on the chip network? And if so, do you think that's a good thing or a bad thing?
So I think that's similar to the question Dill asked in the previous session. I do think there will be market makers. I think having large players will be just fine as long as the protocol stays open and as long as people have the opportunity to compete with those market makers. I think that'll be great. There are a couple of things, is I think there are going to be some built-in limits to how big you can make this database, at least with my reference implementation. Now, somebody will get really smart and they'll figure out how to mega scale this. But right now, the way you scale it is by creating more databases, not by creating a mega database. And it's going to slow down quickly if you put, 1 million users in a database. I don't think you could even keep up. It's going to be hard. So I think there'll be some built-in incentives to scale this as a network as opposed to making mega providers. One last one.
Hey, thank you. Sorry if you covered this already. Is there any localized or globalized view of the state changes in the system that the participants have access to based off of their local trust networks?
Are you asking if the entire system state can be seen from a global standpoint?
Yes.
The answer is no. Each site only knows about its own state, and that's it.
Would they be able to interoperate with other local networks of trust?
Yes. So for example, my hope is that with all the projects that I hear you working on, I would love to see MyCHIPS go into one of these projects, because if there's a neighboring project that's also using it, the minute those are up and running, you're going to have interoperability between the two. And if you get a third one, it's going to go up by more than that. There's going to be synergies there that it's going to go up at a more than a linear rate of utility.
That's awesome. Yeah, we should definitely connect later.
Okay. Thanks a lot for your questions.
Thank you. Thank you.